Hello children. So today we will be seeing multiplication of vectors. As we are saying right from the beginning, a vector will operate on vector algebra. Vector has a direction and magnitude. Scalar doesn't have direction, but scalar has got magnitude. Suppose if we are adding scalar, we have already discussed, just it is primary school addition. Whatever addition we have studied in our school syllabus till up to 10th. 4 plus 4 is 8, 4 plus 2 is 6. But when it comes to vector addition, based on the angle in which two vectors are at, based on that the result will vary. 4 plus 4 can be 8, 4 plus 4 can be 0 also if the angle between the vector is 180 degree, and 4 plus 4 can be any value between 0 to 8 based on the angle between first 4 vector and second 4 vector. Okay, say if this is a vector, its magnitude is 4, this is another vector B, its magnitude is also 4, angle between them is 180 degree, its resultant is nothing but a square plus b square plus 2ab cos theta. Now here theta is 180 degree, theta is 180 degree, so the angle between this vector is 180 degree, so the resultant is nothing but root of a square is 4 square, again 4 square plus 2 into 4 into 4 into cos 180. So what we get, this is 4 square plus 4 square plus 2 into 4 square, this is minus 1, so here what will come? Minus will come. So 16 plus 16, 32, this is 16, so minus 32, finally this will become 0. So just we changed the angle, the result is 0 here. So all these things we have seen. So triangle law of vector addition, if this is A, this is B, this C vector is nothing but A plus B, resultant. Suppose if this is one vector, this is another vector, this is another vector, then the resultant of these three vectors is nothing but this vector. Okay, polygon law of vector addition. This is nothing but parallelogram law of vector addition we have done in analytical method. This formula we have derived. All these discussions are addition, subtraction of vectors. What is unit vector? The vector which just show the direction of a vector. Okay, so any vector can be represented like this. Vector A is nothing but magnitude of vector into this is the direction of the vector. So the direction of vector alone, if we need to find, this is nothing but vector by mode of vector A. All these things we have seen. Today we are going to see multiplication, which is the last part of vector algebra, very important. Okay, so how the multiplication of vectors can be done, we will see. So when we multiply a vector, One possibility is scalar into a vector. One will be just a general number, the other one will be vector. Another possibility is vector into vector. Okay, multiplication of one vector with another vector. So if scalar into vector, if we happen to multiply a scalar with another vector, just like if this is mass, okay, a mass which is moving with some acceleration, and we all know acceleration is a vector. So when we do mass into acceleration, this is scalar, mass is scalar, mass doesn't have any direction, this is a vector. Suppose if we multiply mass into acceleration, mass into acceleration, what we get? We will be getting force. So what is force? Force is a vector. So nothing, in short, what we are saying is, if we multiply a scalar with a vector, okay, the result is nothing but a vector itself. Okay, 2 into 2i plus 3j, the result will be a vector. Mass into acceleration, since acceleration is a vector, the result will be a vector. Okay, so simply we can multiply the scalar with a vector in this type of cases. Say for example, if vector A is equal to 2i plus 3j plus 4k. Okay, this is vector A. Now suppose a number x is nothing but 2. Suppose if I need to multiply the scalar x with the vector A. So this is going to be 2 into 2i plus 3j plus 4k. Okay, multiplying scalar this vector. Just multiply this scalar with each term of the unit vectors. So this is going to be 4i plus 6j plus 8k. Okay, so this is what is xa. Okay, simply we are multiplying scalar with a vector. Clear? This much only, no much complexity. Clear? Suppose if we multiply a scalar into vector, the result will be a vector. Best example is mass into acceleration. Since acceleration is a vector, we will be getting force as the result, and force is nothing but a vector. Simply we just need to multiply this number with each term. Done. Over. Clear? So that's all about the discussion of scalar into vector. Now we will discuss vector into vector. So vector into vector, there are two types of multiplication, two ways we can do. One is when we multiply a vector into vector, one possibility is the result can be a scalar. Vector into vector, we are multiplying, the result is nothing but a scalar. That is just a number. There will not be any ijk, there won't be any direction, nothing. Okay, simply a scalar. So the result is scalar. Okay, vector into vector, the result is scalar. Now this is called scalar product. Scalar product. This is called scalar product. Scalar into vector, we have seen that is not scalar product. Scalar vector into vector, which gives the result, which gives an outcome, which is nothing but a scalar, that kind of multiplication is called a scalar product. Now when we multiply vector into vector, the another possibility is we will get a result as vector itself. We will be getting a vector. So result is vector. So this is called vector product. vector product. Okay, this is called a vector product. So when the result is scalar, we say scalar product. When the result is vector, we say vector product. So when the result is scalar, we call this type of multiplication as dot product. We call them dot product. When the result is vector, that is, we call them vector product. This is commonly used as, commonly named as, commonly called as cross product. Cross product. Okay, cross product. Fine. So when we multiply vector, there are two methods. Once the result will be one side, result will be scalar, which is called scalar product, which is also called dot product. Another possibility is the result is vector product, which is called cross product. Please note it down. So here we are classifying the multiplication of two vectors as dot product and cross product. Dot product, the result will be scalar, so we call them scalar product. Cross product, the result will be vector, so we call them vector product also. So dot product, suppose a vector A, when it is doing dot product with another vector B, the result we are writing as C, which is not a vector, so no need to put arrow here, and we are using the operator as dot product. We are using the operator dot here. So this is not actually multiplication, or we can say we are not using multiplication operator between two vectors. We are using dot product. Here A, this is another vector, but we are using the operator as cross. So this is not that multiplication operator, this is cross, A cross B. Okay, and we will be getting another vector here. So if we are writing C, this will be a vector. Okay, dot product and cross product. Now what is the basic formula of dot product? How we can expand this? A dot B is nothing but magnitude of A into magnitude of B is equal to, okay, sorry, A dot B. How can we write A dot B? How to expand this? So the basic formula is magnitude of A into magnitude of B into cos theta. Magnitude of A into magnitude of B is into cos theta. This is A dot B. When we come to cross product, A cross B is nothing but magnitude of A into magnitude of B into sin theta. Just to show this as a vector, I am putting a unit vector here. We will discuss how to do this in detail. Today we will be concentrating on dot product. So vector A dot vector B is nothing but magnitude of A into magnitude of B into cos theta. Example. So we have studied work. Work is nothing but force dot displacement. This is a vector, this is vector. What about work? This is a scalar. So in physics, work has got its own definition. So work is nothing but the force dot product with the displacement. So force dot displacement. So force is a vector, displacement is a vector, work is a scalar. We are doing dot product here. The result will be what? Scalar. Result will be scalar. Okay, say how to operate this. So work W is equal to F dot S. So this is a vector, this is a vector. So this is what is work. Now suppose this is the direction of displacement. This vector is acting at an angle theta with the displacement. So when we write work is equal to F dot S into, according to the definition, magnitude of force, magnitude of displacement into cos theta, this angle, that is the angle between force and displacement. So theta is the angle between force and displacement. Okay, theta is the angle between force and displacement. Clear? So in this case, this is nothing but, this theta is nothing but the angle between vector A and vector B. Okay, not down. So scalar product or dot product work is equal to F dot S. Another example is power. Power P is equal to F dot V. Force dot velocity vector. Force dot displacement vector. Now force into a displacement or distance vector, okay, we got work when it is a dot product. Another force and displacement, or we can say a distance, when we are doing cross. So here we will have to write R cross F. So this is also a distance, this is also a force, just like this. This is force, this is displacement. Same way this is also a displacement, or we can say a distance into force. But the result here is nothing but torque. So this is cross product. R cross F is nothing but torque. This is a vector. Okay, torque. This is vector. I am telling one example, just we are not going into the detail of this R cross F. Okay, so here this is also a distance. Here this is a displacement. This is also a vector. This is also vector. But the result is, here we are getting work, here we are getting torque. Then how to take the distance and all, this concept we will study in detail in rotational motion. Okay, this we will study in work power energy. Just to understand the difference between scalar and vector product, I am just mentioned this. Do the simple question, find the work done. Find the work done. This is displacement vector, which is nothing but 3 meter. This is force vector, which is nothing but 5 Newton. Angle between them is 37 degree. So work done is equal to F dot S. Okay. So force magnitude is nothing but 5 Newton. Simply we need not put vector sign here. We can simply put the sign as D and F because magnitude is given. So 5 into 3 into what? Cos theta. Okay, this is nothing but magnitude of F, magnitude of displacement into cos theta. Theta is the angle between them. So 5 into 3 into cos 37. So you can remember this triangle. Okay, if this is 37, this will be 3, this will be 4, this will be 5. This angle will be 53, this is 90 degree. So cos 37, remember these values. Okay, 5 into 3 into cos 37 is adjacent by hypotenuse. 4 by 5 will be cancelled off. This is 12 joule. Okay, this is an example of dot product. Okay, so special cases, just special cases means what all effects will happen when we change the angle. So if this is vector A dot vector B, mod of vector A mod of vector B into cos theta. Suppose if the theta is equal to 0, first case, then vector A dot vector B is equal to magnitude, okay, just the numerical value, okay, mod A into mod B into cos 0. Cos 0 is nothing but 1, okay. So this is the maximum value of maximum positive value of dot product, maximum positive value of dot product. Clear? Okay, so its result is nothing but AB. Now suppose if theta is equal to 180 degree, okay, then vector A dot vector B is equal to magnitude of vector A magnitude of vector B into cos 180. Cos 180 is minus 1, so we will be getting minus AB. So this is the maximum negative value in dot product. So when the angle is 0, we will be getting maximum value, that is positive value, but when the angle is 180 degree, we will be getting maximum negative value, okay. Third case, suppose if theta is equal to 90 degree, then A dot B is nothing but magnitude of A magnitude of B into cos 90, which is nothing but 0, okay, we will be getting 0. So the dot product will give no result or 0, the output as 0, the result as 0 when the angle between them is 90 degree. Clear? Note down. Suppose if theta is less than 90 degree, so we will be getting positive value as the output, positive value, acute angle. The result will be positive value. Suppose if theta is greater than 90 degree, less than 180 degree, then the result will be negative value. Okay, just the result is, that is A dot B will be positive, here A dot B will be negative, okay. So based on the angle, the result will vary. Now let us see what is the physical interpretation of the dot product. Say for example, suppose if this is one vector, this is another vector, okay, two vectors, we can say this as vector A, this as vector B, and the angle between them is theta. So we know A dot B, vector A dot vector B is nothing but magnitude of vector A magnitude of vector B into cos theta, or we can say A B cos theta. So this is just A, doesn't have arrow on the top, so this is just magnitude. B is also just magnitude. If we put arrow, we can say that is vector. Simply if we put A, simply if we put B, then they are nothing but magnitude or just values. Now if we know how to take the resultant. Suppose if this is vector B and if this is theta, this is nothing but B cos theta, we have studied this. Now if we take the component of this vector B along A, this is nothing but B cos theta, okay, B cos theta. So just if we look at this, this is nothing but A into B cos theta. B cos theta is what? The component of vector B along A. So this is B cos theta is nothing but the component of vector B along vector A. We can say that, so we can write that A dot B is nothing but A into component of B along A, component of B along vector A. Clear? Okay, remember this. So dot product is nothing but A dot B is nothing but A into component of B along A. That is its meaning. Same way, if we want, if this is vector A, this is vector B, the angle between them is theta. Suppose if we need to take the component of vector A along B, component of vector A along B, if we need to take, then component of A along B is going to be A cos theta. This one, the component of A along B is nothing but A cos theta. So suppose if we take A dot B, vector A dot vector B, if we want, we can write in this way also, B into component of A along B, component of vector A along vector B. So this is also fine. So A dot B can be A into component of B along A, or B into component of A along B vector. Both are fine. Okay, note it down. See the properties of dot product. First property, it always obeys commutative law. It obeys commutative law. That is A dot B is equal to B dot A. Even if we change the order also, it will not make any difference. Second law is it obeys distributive law. Suppose A dot B plus C, that is nothing but A dot B plus A dot C. A plus B dot C plus D. So each one we can operate with this dot product. A dot C plus A dot D plus B dot C plus B dot D. Third property is dot product of vector with itself. Okay, dot product of vector with itself, that is A dot A, B dot A, I dot A, J dot A, with itself give square of its magnitude. A dot B, A dot A is nothing but mod of vector A, basic definition of dot product, mod of vector A, mod of vector B into cos 0. Why cos 0? Suppose if this is the direction of A, then that is the direction of another A. Both are same vectors, same magnitude, same direction. So the direction of both the vectors are same, means the angle between vector from itself is 0. So this is nothing but mod A square. Mod A square is nothing but A square. Okay, note down these properties. Now see dot product of orthogonal unit vectors. See this, what do you mean by orthogonal? Orthogonal means vector will be 90 degree to the another vector. Suppose if we say vector A is orthogonal to vector B, means that vector A and vector B are at 90 degree. Suppose this is one vector, this is another vector. Now they are at 90 degree. They are at 90. So these two are orthogonal vectors. So orthogonal unit vectors, which are orthogonal unit vectors? If suppose if this is y, this is x, y, z, z is towards u. So this is I, j, k. So what is the dot product of orthogonal unit vectors? Means what is the dot product of I and j? I and k, j and k. Okay, so we will see the dot product of everyone. So I dot I, what will happen? A dot A is vector A dot vector B is nothing but modulus of mod of vector A mod of vector B into cos theta, magnitude of A magnitude of B into cos theta. Suppose I dot I, if we do, what is the magnitude of I? 1. What is magnitude of I? This one, 1. What is the angle between them? This is I vector, this is another I vector, so cos 0, so this is going to be 1. I dot I is 1. Same way we can do j dot j is also 1, k dot k is also 1. Now suppose if we take I dot j, magnitude of I is 1, magnitude of j is also 1. What is the angle between I and j? This is 90 degree. So we will put cos 90. Cos 90 is 0. So I dot j will be 0. Same is the case with what? J and k. They are also at 90 degree. And they are also at 90 degree. So j dot k is also 0. K dot I is also 0. So when we do dot products of unit vectors along I, j, k, that will give 0 results. I dot I will be 1, j dot j will be 1, k dot k is also 1, but I dot j, j dot k, k dot I, all these are 0. Dot product of two vectors a comma b in Cartesian form. Cartesian form means what? I, j, k. Suppose vector a is axi plus ayj plus azk. This is vector a. Vector b is equal to bxi plus byj plus bzk. So if this is the case, then a vector dot b vector will be what? So we can multiply ax bx. When we multiply each term, ax bx. So I dot I is what? 1 only. Okay, since this is a scalar result, no ijk here. Plus, what about ix and by? I dot j is 0. So this multiplication will give 0 result. This multiplication will give 0 result. This one and if this one, if we multiply, also 0 result. So what we need to do? Only multiply those respective components, I, j, k components by itself. So ay by plus az bz. Bas, only that much. Okay, suppose if we take one example. Okay, suppose vector a is 2i plus j plus 3k. Okay, and vector b is 3i plus 2j plus 2k. So this is vector a and vector b. So a dot b is equal to what? 2 into 3, 6 plus 1 into 2 is equal to 2. 3 into 2 again 6. So this is going to be how much? 14. So this is the result of a dot b. A dot b is a dot product. The result is just a value, that is scalar result only we are getting here. Take this question. A particle moves from position 3i plus 2j minus 6k. So from this position we can say this as position vector r1 to another position 14i plus 13j plus 9k. So suppose if this is the position r1, this is another position r2. Okay, a particle, okay, this is moved from r1 to r2. Okay, so this is the displacement now. Okay, suppose if this is origin, from this origin this particle's position is what is given here. From this origin the particle's position later shifted to this part. Clear or what? From here the particle was here, from with respect to origin, with respect to someone only we can say the position of the particle. So from here it is shifted to this place. So this position with respect to origin, this position with respect to origin. Now a particle moved from position 1 to position 2 due to an uniform force of 4I plus j plus 3k Newton. So if the displacement is in meters, then work done will be. So what is work done? Work done is nothing but F dot S, force vector dot displacement vector. What is displacement vector? Change in position, R2 minus R1. So what is R2? 14I plus 13j plus 9k minus 3I plus 2j minus 6k. Okay, so what is the displacement now here? 11I plus 11j plus 3k. Subtracted this vector and this vector. Okay, this minus this one. So 11I plus 11j plus 3k. This is the displacement. Clear? I'm sorry, here 9k minus 6k. So minus of minus, this will become plus, we will be getting 15k. Okay, fine. So this is the displacement. Now what is work done? Work done is equal to force dot this vector. So force is given 4I plus j plus 3k dot 11I plus 11j plus 15k. Okay, 11I plus 11j plus 15k. So when you do dot product, what we do? We will multiply the respective components only. I dot I, j dot j, k dot k, like that. So 4 into 11, 44 plus j into 11 again, what, 11 itself. 3 into 15 is equal to 45. So 44 plus 11 is how much? 55. 55 plus 45 is 100 joules. Clear? This is the answer. Work done. Take another question. Find the value of m so that the vectors 3i plus 2j plus k may be perpendicular to the vector 2i plus 6j plus mk. So two vectors are perpendicular and we need to find the value of m. So perpendicular orthogonal vectors, okay, they are at a 90 degree. So suppose if vector A dot vector B, if they are at perpendicular, if these two are perpendicular, the angle between them will be what? Cos 90, correct? If this vector is perpendicular to this vector, then the angle between them will be like a, if this is one vector, this is another vector, this is what they are saying, it is perpendicular to the vector this one. So this is the angle between them is 90 degree. So this is equal to 0. Dot product is nothing but 0. Dot product will be 0 if they are perpendicular. So using that we will be able to find the value of m. So 3i minus 2j plus k. Okay, this vector dot 2i plus 6j plus mk is equal to what? 0. Clear? So 3 into 2, 6 minus 12 plus m is equal to 0. So m will be what? M will be 6. Okay, option B. Finding angle between two vectors. So these type of questions we used to see commonly. Okay, the two vectors will be given. What is the angle between two vectors? So dot product concept can be utilized for finding the angle between two vectors easily. See, suppose vector A dot vector B is nothing but mod of vector A mod of vector B into cos theta. So cos theta is nothing but vector A dot vector B divided by magnitude of vector A into magnitude of vector B. So theta is nothing but cos inverse of vector A dot vector B divided by magnitude of vector A into magnitude of vector B. So this technique can be used in order to find the angle between two vectors. Note it down. So take this question. Find the angle between two vectors. So vectors are given, vector A and vector B. So finding the angle between two vectors. So we know theta is equal to cos inverse of what? A dot B divided by mod of vector A into mod of vector B. Correct? So this is equal to cos inverse of A dot B. How to find? So I'll write this I plus J plus K dot 2I minus 2J minus 2K divided by magnitude of vector A into magnitude of vector B. So magnitude of vector B is root of minus 2 the square minus 2 whole square minus 2 whole square will be getting root 12. So here A into B. So 3 into root 12. Right. So cos inverse of 1 into minus 2 minus 2, 1 into minus 2 again minus 2, 1 into minus 2 again minus 2 divided by root 36. Okay, so again theta is equal to cos inverse of this is minus 6 divided by 6. So this is equal to theta is equal to cos inverse of minus 1. So cos inverse of minus 1 is what? Cos 180 degree is what is? Minus 1. So we will be getting theta as 180 degree. Okay children, so this is the basic idea about the dot product. So in the next session we will see cross product. With the cross product the basics of vector algebra will be done. So after that we will have to move to the next further topics in motion in a plane. Okay children, thank you. Please revise vectors well. Try to do more questions. Practice more so that if you are comfortable in vectors throughout physics, vector algebra is necessary. Your learning in physics will make it comfortable. Okay, thank you. Goodbye. Good luck.